Hi class. Okay, so we continue with the example 2. I will give you example on the template again. So when you get the template means it's a double integral, okay? Alright. Okay, so then a template covers the triangular region bounded by the x-axis and the lines x equal to 1 and y equal to x in the first quadrant. Okay, first quadrant. Then find the first moment. Okay, so the question asks you to find the first moment. Find the first moments. Center of mass. Okay, center of mass about the coordinate axis. Okay, axis. Okay, axis is a plural. And the moment of inertia. Okay, means that it's a second moment. Okay, about x-axis if the plate density is given by this. Okay, alright. Okay, I will repeat again. I will read again the sentence here. A thin plate covers the triangular region bounded by the x-axis and the line x1 and y. So you need to sketch the graph here. Okay, you need to sketch the graph based on this based on this information given in the first quadrant. Okay, then find the first moment. Okay, this one the first thing that you need to do, and then center of mass about the coordinate axis. So first moment we know that we have two, is it? Mx and my. Center of mass, so we have two, x bar and y bar. So the question asks you to find both. Okay, axis means plural, so means that it will be x bar and y bar. Okay, alright, so find the first moment, center of mass for both. Okay, means that this one you should get you should find out mx and my. This one you should find x bar and y bar. And the moment of inertia about x-axis. So means that for the moment of inertia you just find for ix. Okay, only for is. So if the density given by this. Alright, okay, so now what we need to do first, the formula for first moment. Okay, to get center of mass you need to calculate the first moment first. Is it? Okay, so to get the first moment you need to have a mass. Okay, so now we find out the mass first. No, I think not mass. Sorry. The first moment, okay, let's say we want to find mx. Okay. Alright, so mx, so means that here is y. And here is density, right? So dx plus dy. Okay, so dy dx, for example lah. Okay, now you want to find the limit. So what we do is we need to sketch a graph. Okay, y at, so based on this equation, x equal to 1, so maybe here is 1. Okay, this one x equal to 1. Okay, this is x equal to 1 and y equal to x is this one. Okay, y equal to x, so this is the region that you should calculate. Okay, so when you get dy, when you do dy dx, means that you need to draw a vertical line. So you need to find out the enter point and the lift. Okay, at the enter and also the lift. So this one will be 0 and you live at x, and then for dx you see 0, 1. Okay, 0, 1. So you solve this one. Okay, you solve by yourself. Okay, I just write down the answer that you should get here is 5/12. Okay, so this is for mx. So now we need to find my as well. So the changes here is on this part. Okay, the rest will be the same, class. The rest will be the same. Okay, the limit also will be the same, because you are referring to the same graph. Okay, class, so nothing changes, a big changes that you will make. You just change y and x here. Okay, so you done your part now, so you should get here is 3/4. Alright, so 3/4. Okay, done, settle for the first moment. So now we want to go to center of mass. So yeah, center of mass, you need to calculate your mass. Okay, so because of center of mass is over m, right? Same goes for y bar, ms over m. So now we doesn't have m here, m yet. So we will find m. Okay, to find m, okay, we will integrate density. So this is your density. So again, you will use a same limit. Okay, you just copy it. So make sure lah macam ni. Maksudnya, it's easy. It's maksudnya, I mean what I want to say yeah, even though the steps or you need to do a lot of calculation, but for limit, you just use the same limit. So therefore, please check your limit, because of if you're doing the wrong limit, you will affect all of this, okay? So yeah, that's the important part here. Make sure you avoid the careless mistake, okay class? Alright, we're back to the formula for mass. So you done it, you do it by yourself, and then you will get your mass is 1. Okay, you may check with yours. Okay, you do it yours, and then you will check with my answer. Okay. Okay, your mass is 1. So what we do next? Just substitute what the information that you have here. So for example, this is S bar. So my is 3 over 4 over 1. So the answer will be still the same, is 3 over 4. And for y prime is, so yeah, to make it proper, I just suggest you to write in the what you call, in the form of coordinates. Okay, so this one 3 over 4, 5 over 12. Okay, done. So we left with another one is moment of inertia. Okay, so moment of inertia is Ix. Okay class, Ix, and then double integral y prime. Okay, y prime, y square, and then density. Okay, so limit will be the same. Okay, you just using the same limit. So the answer that you should get here is 7 over 30. Okay, alright class. It's easy lah. For double is quite is simple compared to triple lah. Triple of course dia quite tedious lah, because of they have triple kan. But it's still the same. The step will be the same. Cuma to find the limit, for example, to find the limit here. Okay, for double it's just a two graph. Okay, so for triple they have 3 axes, right? So yeah, you need to refer back lah the notes or the video that I will show you for triple integral. Okay class, yeah, that's it for chapter 2. Okay, we are done in chapter 2 already. So yeah, we see you next week in the new chapter. Okay, chapter 3. So chapter 3 is our last chapter. Okay class, dah.